Welcome everyone to latest in Bitcoin tech session. Today we'll be discussing Optech newsletter number 379. So I have like two I found two interesting news items from it, so that to discuss. One is on a proposal to limit the amount of data that a ScriptPubKey can occupy via consensus, and the other one is on a new proposal to introduce a signature aggregation scheme that is post quantum, that is suitable for post quantum signatures, and this proposal is by Draija, the co-creator of Lightning, and the proposal to limit the script key size is by Portland Nodal. We'll have a look into what is the rationale behind it, and what is the pros and cons of this, and also we'll also look into cross cross input signature aggregation schemes, and how it has to be different for um, post quantum signature schemes, and how OpCAV proposal sort of tries to address the post quantum requirements with respect to signature aggregation. So yeah, first things with respect to the idea behind limiting the script pub key size, primarily uh, mm, primarily um, motivated by the need to address UTXO set bloating. Before we get into it, we'll briefly refresh about our memory about existing consensus limits within Bitcoin. So you have a maximum script size, a limit of 10,000 bytes, and also you have this limit that you can only push 520 bytes at using an opcode into the stack in a single push, and also you have this limit on uh, non-push opcodes. Like if your opcode doesn't push anything, um, such opcodes can occupy only 201 bytes per script. There is also this limit of maximum number of keys that can go into an object multisig, which is 20. And overall, the maximum size of the stack at any given time can only be 10,000 bytes. So like these are the existing limits that are put on the script and operations within the stack in order to prevent DOS attacks, and in order to prevent other abuses of the script engine. Within this, there is no explicit limit set for just the script pub key field in your transaction. That is currently that is currently taken care of by the um, maximum script size limitation that is existing. However, because of abuse of the blockchain and people putting in putting in data into script pub keys, there is a need to prevent or put roadblocks, uh, uh, prevent people from using it for non monetary purposes, and that is the rationale behind trying to put a limit on the script pub key size. So in general, if you stuff data in your script pub key, it increases the cost for every node, because they have to like process these script pub keys, and they have to store these script pub keys because they have to validate it once. So that increases the load on your node. and also it bloats the UTXO set because people are stuffing data into script keys, and that becomes a new UTXO, and that hangs around for a while. That is one reason, and the second reason is because right now there are no explicit limits on the script pub key. By introducing this limit, the idea is to align it more towards the other limit that currently exists, which is the 520 byte limit for individual stack element push size. So if we put in the idea is that if you put in the same 520 byte limit for the script puppy size also, like it aligns with the existing limit, and you don't have to do or uh, look for any other conflicts elsewhere. So that's why the proposal is for 520 byte limit on the script pub key. And also there has been studies or people have examined the examined the current UTXO set and have found that um, 99.95% of the existing UTXOs have script pub keys which are less than 520 bytes, which is what is being proposed. And also there are like very few legitimate use case where you will literally need more than 520 bytes of script pub key. And in comparison, like you can see what typical um, typical script pub keys that standard script pub keys that we use occupy. Most of us use a P2W PKH, and that and the script pub key for a P2W PKH um, type of address will occupy only 22 bytes. The heaviest among them is the taproot one, which occupies 34 bytes. So the 520 bytes has the argument is that 520 byte has sufficient room when compared to what exists now. So these are the arguments that are being put forth for the for the for scriptpubkey. How is this different from the existing 10,000 byte limit that the overall 10,000 byte limit that exists for script execution is that the existing limit applies to the process of script execution. That is, you put the script sig and you put the script pubkey on top of it. Uh, and the limit is that when you do this, the total size of elements in the stack should be less than 10,000 bytes. So so this limit is applicable when only when you are trying to verify or execute the script. um, uh, but this one prevents this one aims to prevent denial of service attacks or limit the abuse only when you are executing the script. However, the idea behind putting a limit on script pub key is to restrict the size of the output being created itself, and it doesn't have any effect on the script execution's complexity. So the existing limit tries to prevent abuse of the whole execution mechanism, while the new prospect will have the effect of limiting the size of the outputs that are being UTXOs that are being created itself. So that is a new like let's say new dimension that this proposal wants or seeks to add. um, but there are a lot of um, negatives or cons to it also. The first thing is that the proposal is to activate this via soft fork. So if you try to do that, there is a chance that you will end up confiscating few UTXOs. although people have like surveyed the existing UTXO set and have found that only 99 very few UTXOs that are currently existing have script pub keys greater than 520 bytes. But the argument is that there may be off-chain pre-signed transactions that will that would have been created with script pub keys greater than 520. And if the soft fork goes through, or if you push the soft fork, those unpublished or off-chain and signed transactions will become invalid. Um, so an example for us to understand would be like, there is a transaction A, and it has a script pub key of, let's say, 800 bytes. Then this is a published and mined transaction. Then you have a transaction B, which spends from transaction A, but this is pre-signed and it's stored off chain. It's this transaction B is not published because transaction B spends from transaction A, and transaction A has a script pub key of 800 bytes. If you activate this via soft fork, from that point onwards, transaction B A becomes invalid. So this means you are confiscating transaction A and consequently transaction B also. So the funds get permanently locked, which is not ideal. We don't want to do that. So so this is one of the important objections to this proposal. And another main or important objection is that when you go into post quantum cryptography, uh, right now, whatever signing algorithms that are being discussed or being considered are quite resource intensive. So you might need script pub keys to be larger than 520 bytes. Hopefully, people have come up with solutions that doesn't lead us to this particular situation. But you never know, and you might need it at least for an intermediary time being, or something like that. If we activate this soft fork, we'll be like kneecapping ourselves, and we won't have sufficient room to implement post quantum signing algorithms. So for comparison, if we go with the Sphinx plus, which is a famous or like which is a actively looked at signing algorithm, post quantum signature algorithm, your pub key is likely to be about 1088 bytes. If we go with dilithium, your script pub key is likely to be about 1300 bytes, and if you go with Falcon, it's likely to be around 890 or 890 or 900 bytes. Your script pub key is likely to be. When you compare this with the existing script pub keys are just like 20 bytes, 23 bytes. So you can see the order of increase in with respect to the size or size that your script pub key will occupy. So we might need that space for implementing these post quantum signature algorithms. So yeah, these two are the these two, and there are like few more objections to this proposal. Um, so yeah, this is about the idea and pros and cons of limiting the script pub key size. So if anyone has any questions, I'll wait for a few minutes.
Yeah, Bala, so I have a question. So basically, even if we have a software right now, you told me last time when we had a discussion that the quantum will be definitely a hard fork, right? So even if we change, so if we have a hard fork, we can always change the rules, whatever we have right now, right? So even if we have a soft fork right now, and the even so again, not 556 is the UTXs are going to get locked, but let's say 1000 or 2000. and
Mm,
that's a soft fork right now. And after the quantum thread, it will be hard fork. So we can change everything. All the rules can change. So will it definitely affect it? I don't think.
no, the hard fork is not a foregone conclusion. Not hard fork will be necessary in order for us to come to a conclusion about what to do with the Satoshi era coins. So that is where the debate is. If we settle on the hill, or if we die on the hill that we will not confiscate UTXOs by any means, then I don't think we need to enter into a hard fork debate. We can just introduce post quantum addresses via soft forks and encourage people to migrate their funds, and whoever doesn't migrate are at the mercy of cryptographically relevant quantum computer.
Ah, okay. Didn't know that. Thanks, Bala.
Yeah. So yeah, if there are no further questions, like we'll move on to which is OpCIV means check input verify. Like the name is not formalized. It's just a draft kind of idea. There is not even a pip on this, but there is like um, uh, discussions around this idea of introducing a new um, signature aggregation scheme that is suitable for post quantum signature algorithms. So we'll briefly look at what CISA or cross input signature aggregation. So CISA are mechanisms to reduce transaction size by combining multiple signatures into one. So there have been many studies conducted to illustrate the fact that when you do CISA, you will save a lot of like a significant amount of V bytes when you are creating a transaction. So these schemes basically leverage uh, properties of Schnorr signatures and elliptic curve, and they end up or facilitate you to add multiple signatures algebraically. So that's the basic behind CISA. Right now, Music 2 and Frost are the most prominent or important CISAs available in Bitcoin, which help aggregate your signatures, and this facilitates you to um, uh, not distinguish a multi-sig from a single sig, and also help you reduce the cost involved in such signature schemes. So yeah, these two are the two important CISA schemes that are currently present in Bitcoin. But they require or they need use elliptic curve good elliptic curves to realize these properties. But post quantum algorithms that signature schemes that we are considering, like dilithiums, pings, etc., don't use elliptic curves at all. They are either hash based or they are or lattice based. So with that being the case, and also these signature schemes, as we saw earlier, are quite heavy in size, and you will be happy, or you will be more than having a CISA for these signature algorithms will be more than welcoming. So but you can't do them with Music 2 or Frost. Because Music 2 or Frost uses elliptic curves, and these algorithms, post quantum algorithms, do not use elliptic curves. So we sort of require a CISA scheme so that we can as we saw here, one signature, like this is just a public key, and the signatures are likely to be much more um, heavier than these. So aggregating these signatures will definitely be helpful. So how can we this OptCAV proposes a mechanism through which we can realize signature aggregations for post quantum signing algorithms, signature algorithms. The key difference is that the OptCAV operates at the transaction structure level. It doesn't do much on the cryptographic level like music or frost. It merely operates at the transaction structure level, how you construct the transaction, and what you use to verify the transaction. So it operates at that level. The basic or a very simple or a very crude understanding or um, description of CIV is that it allows you to use let's say your transaction has multiple inputs. You can structure the transaction in such a way that you can use input zero's signature to uh, validate rest of the inputs within your transaction. So it would be sufficient if you can provide the right signature for input 0 only, and based on that you can use that signature to also validate or verify the rest of the inputs in your transaction at a very top level. That's how this idea works. So the opcode opCAV will require you to feed it or put in four different elements on the stack, and it will consume these four different elements. First is the input index, second is the output index, and the third is the TXID of the out point that you are going to spend, and followed by a nonce, which is used to ensure you're using the right input, and also for privacy purposes, followed by the opcode itself. So this is a basic construct of the proposed OptCAV CASA scheme. So the validation logic goes like first the opcode will confirm whether the input index that you have entered is a valid number. Like if your transaction has only three inputs, you should enter an input index that is valid. It can be either 0, 1, or 2. If you enter something like 4, 5, 10, it will consider it as invalid, and the script will fail. So that is the first thing. Second is the you have to provide the out point, TXID and output index, which verifies that which is used to pick which UTXO you are going to spend within which UTXO you are going to spend. So that information you have to provide, and you also have to provide a nonce for privacy and DOS prevention purposes. So this is how the validation will go. If all these checks clear, then the script succeeds. Otherwise, the transaction becomes invalid. We'll look at how it goes about validating. So we have three inputs: input 0, input 1, and input 2. So you will be providing the signature for input 0, but you don't have to provide signatures for input 1, which is UTXO B and UTXO C. All that you have to do is provide a reference for UTXO B and C, saying that if UTXO A is signed and verified, then allow the script to spend from UTXO B and C also. So that's the whole logic. um, so these two inputs look to input 0 for truth or verification, and if this input 0 is spendable or is has been provided with the actual correct signature, then you can go ahead and spend from or consume UTXO B and C also. So this is the mm, uh, mm, basic idea behind this CISA. The important point to note is that even though we are going to consume three UTXOs, the signature verification happens only for one UTXO, and that sort of reduces the size of your transaction, because you're not going to provide signatures for all these other UTXOs. This is important in the post quantum scheme, because it can drastically reduce the size of a transaction. So that's a flow chart of how it will work. So now I'll pause for a minute. If there are any questions, I'll try to answer. Okay. So next we'll briefly look at how this OpsAV is set up and how it is spent. So so we'll continue with the same example. We have like three UTXOs that we are trying to put it in a CISA scheme for post quantum spending using OpsAV. So all these things will happen uh, in a taproot structure. So you'll put UTXO A with a particular TXID and B out, and an amount that will be set up as a standard key path spend in your pay to taproot address, and that means like it can be spent by providing the right signature for this UTXO. Second UTXO, you will set it up as a leaf, as a leaf with the script as noted here, which is nothing but the script that we require for OpsAV. So you just put the script in a leaf path spending, so that becomes your UTXO B. And similarly you construct another leaf for UTXO C. So now you have the three UTXO housed in this pay to taproot address, and in order to spend this pay to taproot address, you can all that you have to do is provide a valid signature for UTXO A, and provide the right nonces for UTXO B and UTXO C. So the nonce is calculated like this: the hash of the master private key of this UTXO B concatenated with the TXID or out point. Similarly for C, its private key with its out point. You have to supply you have to provide witness data for spending UTXO-A, followed by these details, and then you will be able to consume all three UTXOs, like all three UTXOs in and move them to a new or spend them out. The point to be noted is that you are saving space by only providing signature for UTXO A, and also during verification The script engine uh, doesn't have to calculate the signature for all the inputs. It just have to have just have to calculate the signature for the first input, and it's good to go. So that's the idea behind this signature aggregation path. So while spending the key point to note is what should you provide in the witness. So as we discussed earlier, we'll provide a valid star signature for your UTXO-A. So that will be the only signature that you will be providing. For in order to consume UTXO-B, all that you need to provide is the required stack elements for OpCIV, which is nothing but the out point details followed by the nonce. And similarly for in UTXO C, you will provide its corresponding out point details and followed by the nonce. So when you provide these things, the mechanism that we described here will happen. That is OpCAV opcode will enact all this, will orchestrate this process. So it will just consume the signature for UTXOA. It will verify whether the signature is correct, and if this signature is correct, then it will move on to executing this the OpCAV part of UTXO-B and UTXO-C. When it does that, it doesn't look for a signature for UTXO-B and UTXO-C. Rather, it looks whether UTXO-A A's signature is valid, and whether you have provided the required whether your out points are correct, and whether you have provided the required nonce. And if these things are okay, then the three UTXOs are consumed in the transaction, and the transaction goes through. So yeah, the all three inputs are validated with just only one signature. So that's the whole idea behind this OpCAV setup. So yeah, and there are more details to this OpCAV as to why to use this nonce, and how this tap taproot spending occurs. So that um, maybe we can like look into it in much more detailed fashion in another session. So yeah, this is just to give a brief overview of what this new proposal of cross input signature aggregation for post quantum signature is about. So yeah, if you have any questions or points of interest, we can discuss.
Okay, Bala, a dumb question. So this is valid for every type of, so whatever post-quantum
Yeah,
signature we're going to use,
yeah,
it
yeah,
is valid
yeah.
for everything. Yeah. Okay.
Yeah, basically, most of the signature algorithms that are currently under considerations are either hash based or lattice based. Anything that you pick will work with OpCAV.
And so is there any competition to this, or this is the best thing they have come up with?
Uh, right now, nobody's working on signature aggregation schemes, particularly for yeah, post quantum algorithms. I think this is the only proposal that I have come across. But yeah, I don't think anyone else has floated any other proposal for signature aggregation in post quantum.
Okay, and so how much, so percentage-wise, if you have to guess, how much is better than Frost or other type of keys?
Uh, no, Frost and music too will only work with elliptic curves. That is, if we move from ECTSA, music 2 and Frost will not work. So we need some other signature aggregation schemes like OpCAV.
Oh, okay, okay, got it, got it. Thanks.
Um, if there are no further questions, yeah, I think we can call it a day. And just an announcement. We discussed a vaulting protocol a couple of weeks before. The proposer of that protocol had a had a look at our video, and he wants to get on a session and clarify some. I think we were discussing some shortfalls that could be there in the vaulting structure, and he like was willing to clarify it, and we'll be hosting him next Monday.